Hello viewers, welcome to my channel KK Concepts of Electrical Engineering.
For perfect dielectric material, we got the boundary conditions that E tan 1 equals to E tan 2 and D tan 1 divided by D tan 2 epsilon 1 divided by epsilon 2. For normals, D n1 minus D n2 equals to rho s for the surface charge density. If the surface charge density is absent, then dN1 equals to dN2. Now I am considering a interface where dielectrical material 1 is here, dielectrical material 2 is here. For this, permittivity is epsilon 1. For this, permittivity is epsilon 2. Then I am having a D1 and this is a D2. Let this be theta 1 and this one is theta 2, this one d tan 1 and this one d n1 and this one d tan 2, this one d n2. Refraction of D2 at dielectrical interface. Let epsilon 1 is greater than epsilon 2, then d1 is greater than d2 and e1 is greater than e2. The direction of E is similar to the direction of D since D is equals to epsilon naught E. From the figure, D2 equals to dN2 whole square plus d tan 2 whole square under the square root. D2 equals to square root of dN2 equals to dN1. So dN1 whole square plus d tan 2. D tan 2 equals to d tan 1 multiplied by epsilon 2 divided by epsilon 1. So d tan 1 multiplied by epsilon 2 divided by epsilon 1 whole square. Substitute the value of dN1, d tan 1 from the figure. Then there is square root of d1 cos theta 1 whole square plus epsilon 2 by epsilon 1 whole square d1 sin theta 1 whole square. Now from this d1 whole square is common, then cos square theta 1 plus epsilon 2 by epsilon 1 whole square sin square theta 1. D2 equals to d1 of square root cos square theta 1 plus epsilon 2 divided by epsilon 1 whole square sin square theta 1. Let this be equation number 1. Now substituting the values of E in terms of E in equation number 1, then epsilon 2 E2 equals to epsilon 1 E1 square root of cos square theta 1 plus epsilon 2 by epsilon 1 whole square sin square theta 1. E2 equals to epsilon 1 divided by epsilon 2 of E1 square root of cos square theta 1 plus epsilon 2 by epsilon 1 whole square sin square theta 1. E2 equals to E1, taking this term inside the square root, epsilon 1 divided by epsilon 2 whole square cos square theta 1 plus epsilon 2 by epsilon 1 whole square multiplied by epsilon 1 by epsilon 2 whole square sin square theta 1. These two terms gets cancelled. Then E2 equals to E1 square root of epsilon 1 divided by epsilon 2 whole square cos square theta 1 plus sin square theta 1. Let this be equation number 2. Now from the figure, tan theta 1 equals to opposite, that is d tan 1 divided by adjacent side is d and 1. Similarly, tan theta 2 equals to d tan 2 divided by d and 2. Tan theta 1 divided by tan theta 2 equals to d tan 1 divided by dn1 multiplied by dn2 divided by d tan 2, that equals to, now we know the condition. From the condition, dn1 equals to dn2, so gets cancelled. Then d tan 1 divided by d tan 2, which is nothing but from the conditions, that is epsilon 1 by epsilon 2. Now we can write tan theta 1 divided by tan theta 2 equals to epsilon 1 divided by epsilon 2, and this is known as law of refraction. From all this discussion, we can say that D is larger in the region of large permittivity, E is larger in the region of smaller permittivity, and it is possible to find the field on any side of the boundary if the other side is known. Our boundary relation for dielectric material is given by this.
If you have any suggestions and queries, please mention in the comments. If you like this video, please like, share, and subscribe. Thank you for watching the video. Please stay tuned for more videos.